Hello, everyone. Is the Prophet Michael David, aka Aries, and today we are going to go over my solution to the Collatz conjecture. Okay, so here's my algorithm, so you don't have to like screenshot the thumbnail of the wiki. I almost forgot for all of you that don't know what the Collatz conjecture or the 3x problem is. It's just a game. Pick any number. If it's odd, you multiply it by 3 and add 1, hence the 3x plus 1. And if it's even, you just divide it by 2. And his conjecture was that no matter what number you picked up into infinity, that eventually you will always go back down to 1. So here is my proof of the thumbnail of this video, which is the proof, but I'm going to do it in 3 different ways. I'm going to do it metaphorically first, I'm going to do it visually, and then I'm going to do it mathematically for all the mathematicians at the end. And I'm doing it not totally, but for a lot for this man, David Hilbert, which I'm going to screenshot in this quote, in which, he says, like, a mathematical proof isn't a proof. You can't prove anything unless you can explain it to normal people, you know? So then I thought, being a prime number theorist, what would this all look like in base 6? And this is what it looks like. As you can see, when you split the number line into the 1 mod 6 lines in this Collatz conjecture, the 4 mod 6 line has way more highlighted numbers than any of the others, and this is why that is. I just realized in this moment how much I had to condense this. So 2 to the n numbers are the real numbers, you win automatically. The magic numbers are the numbers that send you to the 2n numbers so you can win. The progeny are the numbers that send you to the magic numbers that send you to the 2n numbers. And the teal numbers are the actual odd numbers that give you the progeny numbers that send you to the magic numbers, which send you to the 2 to the n numbers, which let you win the game. And I also realized that for some of you that aren't real mathy people, that I have not kept my promise to give you analogies about it, which I will do at the end. I'll come up with it's a basketball analogy, but it's going to continue to be mathy for now. So then I realized if you just add odd numbers to the 3x plus 1 line, you get the 4 mod 6 line. And then I knew the 4 mod 6 line had a bunch of numbers that were only divisible by 2, but at least 1 2, but a lot of them are divisible by more 2s. So I tried to find out how many that was. And as you can see, once I did that, I realized that every number in the 4 mod 6 line was divisible by 1, every other one, but they were divisible by other numbers that seemed kind of random, but I decided to graph them, and this is what it looked like. So this graph shows that any 3x number, if it only has 1 2, then that happens 50% of the time. And the rest of the time, whether it has 2 2s, 4 divisible by 4, 3 3s divisible by 8, up to infinity, that happens the other 50% of the time. So then I thought, instead of adding up all the 2s, why don't I just add up all the different probabilities for all the different odd numbers? I mean, if it's 50% chance to be only divided by 2 once, and 1/4 chance to only be divided by 2 twice, and everything, I could add up all those different probabilities and see what they become. And so I made this graph. Spreadsheet, not graph. But then I programmed the spreadsheet to kick out all of the probabilities for all of the 3x plus 1 numbers, and then did their summations, and then divided by x to get the average summation. And yeah, that's how I did it. So as you can see, at x, the first odd number equals 1, the summation divided by x minus the quantity of x minus the summation exactly equals 1. And you can also see at the end of the spreadsheet, although it can go to infinity, that again, the sum minus x is minus the x, the quantity of x minus the sum is also 1. Now you're asking, is the answer 1 anywhere between 1 and infinity, or the end of whatever, how many subsets of derivatives you do? And the answer is no. And so I just decided to graph it, and this is what it looks like. All right, here, my conjecture that's not really conjecture is like the more subsets, like the more divided by 16, 32, 64, 128s that you do to this analysis that I did past what I did, the more that those two equations will look like a black body curve on the top and a semi-black body curve on the bottom. They're equal to 1, they go to a maximum, and they go back down to 1. My other conjecture, it's pretty obvious that the bottom one will go down to 0, but only at infinity. And which would mean that the peak of the top one, I meant the peak of the bottom one, and the peak of the top one will go up to infinity, but only after an infinity of factors. So that's my conjecture, non-conjecture on having, the Collatz conjecture. So at this point, anybody that's watched any of my videos, or maybe just this video, so what were my ambitions or drives to try to solve this equation? Because if you've seen any of my other stuff, solve the twin prime conjecture. I'm working on Riemann hypothesis, but I had no business going into the Collatz conjecture, especially with its notorious reputation. So why did I do it, and how long did it actually take me? So just messing around on YouTube one day, probably in between Tupac songs, and I don't know, whatever, the algorithm popped up. That video popped up and I watched it, and all I can say is, like, I was drawn to the presentation. It was very good. How he described the problem was very good. I loved the video, and I realized at the end that he was wrong. But then I saw that there were no comments underneath the video, that he had turned them off, and instantly I knew why. It was because there was a bunch of trolls that said, dude, you haven't proved anything but that you know, 1 equals 1, or that, you know, whether you start here, no matter how you go up, you get to 1, it's going, the ups are going to equal the downs, but they probably did it in a real trollish way. And so he turned the comments off. But the one thing that I did take out of the video, other than that, was that the way he described that 3x plus 1 can also be described as x plus 2x plus 1. That you're taking the original value plus 2x1. You're adding and multiplying at the same time, which is kind of like a property that goes through all great math problems. So at that point, I had my normal job of trying to solve the Riemann hypothesis and try to convince the world that I'm an end times prophet to help you all and everything. But in that moment, I was as angry as a person with nirvana with a remainder could get. But yeah, like even without the comments, I could see what happened to him. And so I decided I would look into the Collatz conjecture and see if I could figure it out. You know, I've been working on Riemann for so long, and how long it took me to solve was an afternoon, basically 3 hours. I swear, I did in 3 hours. Now, thinking about what I say to you guys and even constructing this video has taken more than 3 hours. But to solve the Collatz conjecture and understand why I solved it only took me about 3 hours. All right, real quick, I'm not going to do my average sign off with the two rules. I'm going to do with something different as commanded by God or ordained by God. But let me just say, any of you that want to throw my theory off the pedestal, I'll give you a couple of reasons why you can't. Number one, it proves that except for unique circumstances, the Collatz conjecture theory, whatever, 3x plus 1 game, you really only deal with 2/3 of the numbers, 2/3 of the evens, and 2/3 of the odds. So if you want to prove me wrong, just, you know, don't pick a number that's 3 mod 6 or 6 mod 6 and just do the number with the 1 mod 6, 2 mod 6, 4 mod 6, and 5 mod 6 numbers. And even more than that, just put my algorithm, make some for you programmers, make an algorithm that double blinds it, where you don't just random number and you don't know what the random number is, but you just put my algorithm up and have it light up each as it steps to each number, and you'll see that even if the algorithm picks a 3 mod 6 number, it's instantly going to throw it on the 4 mod 6 line, and then the game begins. Or if it's a 6 mod 6 number, depending on how many 2s it has, it'll go 6 mod 6, 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 until it throws on 3 mod 6, and then 3 mod 6 will throw it on 4 mod 6, and then the game will begin. In other words, to solve the Collatz conjecture, you just have to prove that it doesn't go to infinity at any time. In that single solution, the thumbnail of this video, the Collatz conjecture, the Collatz number, no matter what you can pick, can no further go to infinity as the number can jump off that page. Infinity might have a mod number, no mod number, a mod number, all mod numbers, but any number under infinity does have a mod number. And if they have a mod number, they'll jump around that page and they will ultimately end at 1. So in conclusion, how did I solve this, especially so quick? Well, I'm a prophet. But the other case is modern mathematicians and people of all whatever, you know, they're all stuck in one segment of thinking. They can't think out. They can't think outside the box, let us outside the cube, the hypercube, or whatever. But I can and everything. But to help you all with this, in this particular problem and everything, you can look at all the different trees, Collatz conjecture trees on the internet. They all just were looking at the wrong trees. They needed to do more thinking. I mean, if they can do that, that's fantastic. But they didn't do enough thinking. But to help you all with this, you need to look at the right trees in all aspects of all your lives. You need to try to find the right trees. So signing off, here we go.